So I was browsing the World Wide Web one day and came across this wonderful Twitter post right here. Thought it looked pretty cool and wanted to make it myself, so that's what this video is about. So the actual dot thing is made in Blender. I'm just not a Blender guy though. Just didn't want to load up an image and get this in Blender. I wanted to make something a little more accessible. I could make it in Unity, which is my program of choice, but because I've recently been learning a bit about web development, I figured I'd try to make it into a website. From there, I opened my handy dandy VS Code and got to work. Let's break down what's happening in this post. 1. There's an image. 2. There's a bunch of dots that are moving around, running into each other. 3. Those dots are changing their radius, maybe? Based on the image, there might be a secondary radius as well, because the small dots seem to be avoiding each other. And 4. All dots are white on a black background. I started recording after I set up a basic environment to upload an image, so that's where things start off here. So, to start things off, I needed an image to work with. So I got the image that was uploaded to display itself on the web page. I then know that we'll be working with white dots, so I figured I'd have to grayscale the image to get the correct values. The value of a color is how light or dark the color is, so if we're getting the values of each pixel in an image, it just means that we'll get a number from 0 to 1 on how dark 0 or light 1 the color of that pixel will be. Now, I haven't done any image processing before, so I had to do a little bit of research. One of the first posts that I saw about this topic was on Stack Overflow, and it was talking about an image processing framework called Marvin J, which made it look pretty easy to apply any type of filter I wanted to an image. This ended up being more overcomplicated than what I wanted, and got results like this.
That's not good.
After a bit of tinkering, I just decided to ask ChatGPT how to loop through pixels and went with that. Now I just need to figure out how I'm gonna grayscale. I love GitHub Copilot, man. I now needed to add some dots. The idea that initially came to my mind is to have a div element that would embody a dot, so that way I could style it with CSS like any other HTML element. So I added a nice little dot to the top left of the canvas, or rather 100 dots randomly positioned on the canvas. I then gave all those dots some movement, and it was kind of at this point that I realized I'll probably need a way to differentiate each dot's speed or velocity or size, anything that would be unique to each dot. So I made a class for dot and added velocity. I then made a move function that would just move the element that was being tracked by the dot in the direction that it was supposed to move. So now I have a dot tracking its own movement and correctly bouncing off walls. If I then apply that to each dot, I have a canvas of moving dots. Oh, epic. And then again, it was at this point I realized that if I'm gonna have like even 1,000 dots, which means 1,000 div elements all changing their CSS styles at the same time, it would lag the browser like crazy. This was not great and kind of disappointing because even though I hadn't worked for very long on this project, I would need a different solution to moving thousands of dots. My thought here, after running into the first roadblock, was to use an HTML canvas. With canvases, I can redraw each dot every frame based on the position where the dot is. I would just use the dot class that I made earlier to keep track of the dot's position as well. I didn't know how different this would be performance-wise, but I had to try it because this div element solution wasn't the play. And I can't do 1,000. Already I could see that this was a much more performant process. Even though I hadn't gotten it working quite yet, I was able to draw a couple thousand dots on the canvas, with the browser still running fine. My first breakthrough in getting a decent solution was adding a nice little clear canvas before I looped through all the dots. Oh my god. That kinda works. This way, every frame, I was clearing the canvas and redrawing all the dots in their new positions. The next goal was to get the dots interacting with each other. GitHub Copilot is wonderful at giving suggestions, and to my surprise, it actually gave me a decent result. Obviously, it's not perfect, but it's a pretty good starting point. I also messed with the radius of the dot just to see if I could get something working, and then a few more changes to the collision, and I had the dots bouncing off of each other correctly. That actually looks like it's working. After a little more thought on how the particles actually interacted with each other, I realized that the smaller dots weren't actually coming into contact with anything. It's like they had a second large radius that handled the collision and a smaller radius that just handled the graphical aspect. So I added the larger radius to just be the size of the largest dot. So that way, when the dot was the largest, its visual radius and collision radius were the same size. So they would just bounce off each other like normal. But when the dot is smaller than the max size, it would bounce off of other dots from a further distance away, thus leaving more space in between each dot, representing a darker area. Now that I had an image I could process, and dots that were moving around, it was time to actually start having them interact with each other. For the dots to interact with the image, I needed a way of mapping the position of the dot to the correct position of the image. For this, I used a percentage system. So if the dot was in the position 25%, 25% on the canvas, then the corresponding pixel would be the closest pixel to the matching percentage of the image, 25%, 25%. If I did this for every dot, I could get the approximate pixel color of where each dot should get the pixel data from. This was a useful way to color the dots, but now I could also get the value of the pixel. And based off the value of the pixel, we can adjust the radius of the dot to match said value. Perfect. Now that we have the radius working, go ahead and tell me what you see. That's right. Give it some time. Really take a look at it. Really nicely glaze your eyes upon this picture here. You don't see anything. There's nothing. What the hell is it? What is even going on right now? Yeah, I can't tell what the fuck that is. Okay, so we still have a little bit of work to do. To start, let's make the canvas the same aspect ratio as the image. That might help a little bit. Might be a little bit easier to tell what's happening. And even if I squint really hard, there's nothing. Still nothing. Another problem is that I'm trying to look at a bright red canvas with low contrast image and differentiate between small dots. That doesn't really work. Let's make the background black and find a Blender image that might go better with what we're trying to present. See, at least here, if you squint really hard, you can tell a little bit of what's happening. And if we add a few more dots, it makes it even clearer. But with this arises a new problem. 2,000 dots here is good, but we're still running into lag. Luckily, I make games and run into lag quite a bit, especially because I'm developing a split-screen RTS where there may be 1,000 units on your screen at the same time. Check it out. A classic solution to handling many objects on your screen at the same time is to set up a spatial grid. Let me explain. Let's say we have 100 dots, and each frame, the dots need to know whether or not they're going to collide with another dot. To detect this, a dot will check every other dot on the screen and see if it's within range to collide with. If it is, well, then we know we can change certain things based on this collision, like move speed or direction. But you may have picked up the problem already. Every dot is checking every other dot every frame. So that means if we have 100 dots on the screen, each dot is checking all 99 other dots to see if it's within range. This can easily become performant heavy as we increase the dots. My solution to this is to set up a grid. Each grid cell keeps track of the dots that are within it, so that way we have references to all the dots available whenever we want. So once we decide to check for nearby dots to collide with, what we can do instead of checking all 99 other dots is we can just check the dots that are within the nearby grid cells. This drastically reduces the amount of distance checks we need to perform every frame and thus reducing lag. So now let's see how 4,000 dots are handled. Or maybe 10,000. Okay. Maybe 10,000 is a bit too much, but we've definitely improved since the initial dot test. Now, this looks great at the start, but if we let it run for a few seconds, you'll see that the dots almost start to disappear or maybe like fizzle out. If you look at it logically, when a dot is larger, it's going to run into more things, and if it runs into more things, each dot is inevitably going to move into places with the least resistances, which just so happens to be the places where the dots are really small. So that means, as this runs, the dots are just going to move into places where we can't see the dots. To try and fix this, I wanted to add a respawn feature to each dot, so that when the dot moved into a location that was too dark, it would respawn to a brighter location. The original post uses this as well. They just do it really well, and I don't. The results of this ended up looking pretty cool, and it was at this point that I thought I was pretty close to the final product. Add 10,000 dots and you almost got an HD image. But this still wasn't good enough, in my opinion. How can we improve? Well, first of all, we're getting detail in the really bright spots of the image, and the dots just aren't moving enough to reach all the different locations of the image. The collision just wasn't what I wanted either. Everything looked a bit too static, whereas in the original post, everything was moving around very nicely. And once I separated everything out a bit, the respawning was looking very jittery, like all the dots were squeezing their way in between each other. I tried messing with the movement direction a bit. I tried messing with the grid sizes. I tried messing with the velocity changes when they collided. This one looks kind of cool, but completely useless. Here's some other variations that I tried as well. After a bunch of disappointment and tinkering with values, I looked back at the original post, really trying to analyze and see what the dots were doing. And it made me think of something. There's a video from a person named Sebastian Legg, maybe you've heard of him, about a concept called Boids. Boids is an artificial life program that was invented back in the 80s to try and simulate the pattern of flocking birds. Now, I don't know about you, but I can definitely draw some comparisons between this post and the Boids algorithm. So the Boids algorithm is based on 3 parameters: separation, alignment, and cohesion. Separation is how Boids move away from other Boids if they're too close. Alignment is how Boids attempt to match the move direction of neighboring Boids. And cohesion is how Boids move towards the center of mass of their neighbors. If you want to learn more about Boids, I would recommend watching Sebastian Legg's video. I've also posted some other papers about Boids in the description. And with these 3 rules, you can get some rather organic looking patterns to show up. And also, because I switched to Boids, I just made the canvas loop the dots rather than bounce off. And I also added a little debug draw mode so you can actually see what's happening to the dot and how it's interacting with its neighbors. Now it's just up to tinkering with some values until I get something that I like. After quite a bit of tweaking, I may not have gotten it exactly, but I got something that I think looks pretty cool. If you want to try it out, I put the website in the description, so it should be right at the top. Made it look nice and added a bunch of sliders for changing various settings if you want to mess around with it. Let me know how you like it. Send me some screenshots or videos. Like and subscribe.